We got audio?
Hey, looks like we all got dropped there for a second.
Yep. Do we have audio back? Am I back?
Yeah, you're back.
Awesome.
I can hear you.
I am horribly sorry for that.
I may never recover from the shock.
I know.
I've been delivered.
Was mine the only Zoom session that got dumped?
No.
Oh yeah, it was just you.
Okay.
No.
All right, now we're live. Hello, everyone. We are back. Sorry. Zoom has a new feature, apparently. Like, it talks to other computers on your network to control Zoom meeting functions. That's weird. Anyways, so here we are. I don't know what intro of any we got. So let's do it again. I'm Chris Short, executive producer here on OpenShift TV. Scott, I'm handing it off to you, who can then introduce everyone else. So this
fantastic. Thank you, Chris. Thanks for having us. We're on our third session here of Red Hat Advanced Cluster Management Presents. It is a mouthful, so we can call it RHACM today. I'm a product manager with RHACM, and we're focused on the multi-cluster problem, solving that challenge with management around OpenShift clusters. I'm going to turn it over to Josh Packer for his introduction.
I'm Joshua Packer. I lead our cluster lifecycle and our application lifecycles on ACM. There, I shortened it even more for you. And yeah, we're here to talk about lots of cool stuff today.
All right, and let's go. Gurney, you're up next.
Oh, goodness. I'm Gurney Buchanan. I am but a lowly software engineer on the RHACM CI/CD team. We've done a lot of work with CI and CD at the multi-cluster scale. We're kind of the guys that test and get RHACM out the door, so we get to solve all those fun problems.
And Gurney's the only engineer that actually knew what Twitch was when I came forward to ask these folks to come in. He's like, oh yeah, I got tons of friends on Twitch. I'm a big fan. Tim, how about next?
Yeah, I'm old enough not to know what Twitch is. So my name is Tim Poyer, and I lead up the CI/CD. I'm a lead architect of the CI/CD process for ACM. So we figure out how to take all the lovely code that all these beautiful, smart developers put together, and we throw it into a bucket and figure out how to make it run. So so Gurney is part of my team, and I'm excited to be here and talking about some of the stuff we're doing today.
Lots of good stuff. And without further ado, how about Devin? Take it away.
Hey, I'm Devin Goodwin. I'm a principal software engineer at Red Hat. I lead the OpenShift Hive team, which is a small component of RHACM, and just here today to give a brief intro to Hive because I think it's going to come up a few times.
Yeah, it's kind of a big deal for ACM. Chris, as you know, you got involved with us in the hackathon we did, I think it was April, but our journey really began, I think it was kind of October, November of last year, when we got together in a room in Raleigh at an IBM site with Devin and 15 of his wizards. Josh was there, Tim was floating around. I mean, it was literally a hackathon. And that was where we started to put together the bits and pieces of ACM with Hive providing, clusters as a service, the whole concept of the multi-cluster management on top of OpenShift, and really bringing the best of both to the next level. That's where I got to know Devin and got to learn more about what that team is doing. But I was blown away from that point. And when I heard that they were using Hive in production on OpenShift dedicated, it was like, okay, this is a win-win. This is a perfect marriage. So Devin, you've got the history there, and I thought maybe you want to share some insights around what you've been doing with Hive over the past year and a half.
Sure, thanks. Hive is a Kubernetes operator for provisioning, deprovisioning OpenShift 4 clusters, and some day 2 management, not a lot, but certain things that are needed when you're dealing with a lot of OpenShift clusters across the broad fleet, or just provisioning and deprovisioning a lot at scale. So we built Hive to just give you that API to do that, declare the clusters you want, how you want them configured, be able to mutate certain things and have that constantly reconciled. That's all done via Kubernetes custom resources, as it would be with most operators. OpenShift 4 itself, we hope we aim to have it self-managing and self-healing as much as possible. And Hive sits at sort of a layer above that for the things that don't make sense to do within a cluster. We try to just help you get them bootstrapped to the point where you can work within the cluster or with a more feature-rich solution like ACM. It's been a open source project since day one. It's available on GitHub, but OpenShift/Hive, and we publish weekly to Operator Hub. When we formed the team and started the project, our first goal was to help the SREs who built OpenShift dedicated. So we wanted to reduce the time to get clusters up. We wanted to help reduce the human intervention and toil required to configure, manage them. That was the driving factor, or our first use case that we tried to satisfy with Hive. And that has been successful. That Hive powers almost all OpenShift 4 dedicated clusters today. And we work closely with those SRE teams to make sure that it exposes the features they need to be able to deal with so many clusters. And of course, since then, we've integrated with RHACM. And we've even seen some adoption just with, not in terms of an official product, but just customers who found the open source project and were interested and started using it for their CI workflows for developers. And that sort of thing. Basically, we just make it, we offer APIs such that you can provision your clusters. That's all backed by the same installer that you would use if you installed OpenShift 4 on the command line, OpenShift-install. And that works across AWS, Azure, GCP, VMware, OpenStack, Rev. Hive will help you automate DNS in terms of setting up the delegated zones for a new cluster. We can help you deploy your control plane certificates. We offer machine pool APIs so that you can manage the machine sets that are in your cluster on an ongoing basis, bring in new pools of machines and nodes that you want to run specific workloads on, spread across availability zones automatically like you would get when you do the OpenShift installer, but not something you can do once the cluster is up today, unless you do it yourself. We do have a rudimentary mechanism for delivering arbitrary config to clusters, but there are much better options available in RHACM. And a couple of things that we've done more recently that will come up, I think, a few times today in the demos, but we make it such that you can hibernate and resume your clusters to save on costs when they're not in use. And we'll also handle the product gains support for that somewhere around 4.5.8, and we just integrated with it. And we also handle the edge case where you might bring your cluster back to life after its certs have expired. And CSRs need to be approved, so we can handle that for you. And we've also introduced the concept of a cluster pool where you can keep a selection of a fixed number of clusters up and running and ready to go. When needed, they are hibernated once they're ready, and then they can be claimed by any user with permission to do so and assigned out and then immediately replaced in that pool.
And specifically that cluster pool capability is something we're going to talk about today that from a CI/CD perspective has been very valuable for us, not only in a cost saving mode, but also just in a time to provision, right? We don't have to wait around for 45 minutes for an OCP cluster to be provisioned. We just get one right away, right? Which is fantastic. And one way I started to think about Hive, and I don't know if Devin would agree with me on this or not, but it seems easier for me to think of it this way, is that Hive is it's an operator for OpenShift clusters, right? Now I can't control every aspect of an OpenShift cluster from Hive, but I can control many of the most valuable functionalities of operating an OpenShift cluster with Hive, and bringing that operator type control into this paradigm of like infrastructure as code is a very, very powerful concept, and one that I think many of the viewers will probably gravitate towards.
Well, that's that whole concept, Tim, where we don't treat the clusters like pets, right? We want to be able to spin up a cluster in the shortest amount of time possible, make use of it, provide it to the developer, to provide that stack to anybody who needs it without a bunch of, where you're just sitting there.
Absolutely. Think about.
You mean bespoke artisanal Kubernetes clusters aren't the goal?
Think about 2 years ago, right? Or 3 years ago, when people were really starting to evaluate Kubernetes and start to understand it. And you get in there and once you understand what Kubernetes does, then you're talking to developers and you're like, well, this pod's not working. Well, we'll just delete it. And they look at you with this stunned look, this almost like deer in the headlights. What do you mean you're going to delete it? Like, well, the pod doesn't mean anything. It's the deployment that means something, right? Kubernetes is just going to recreate the pod. And to bring that kind of concept to the cluster level, right, where the cluster stops meaning, everything to you, and it's more the configuration of the cluster that is the meaning that's the value is in the configuration, right? And the applications that are scheduled to deploy and run on that cluster. So if I can, destroy a cluster and bring up another cluster somewhere else, and all my applications are automatically synced to it and deployed to it and running there, wow, like imagine the weekends we can give back to people.
And that last part, Tim, the applications, right? The workloads. It's one thing to have the cluster as a pet, but to know that the applications are going to sync back there, the workloads will come back based on your desired state model. That's what ACM brings to the table. We not only give you that cluster lifecycle capability through Hive, so provide clusters as a service, but then also be able to provision the workload on them as it was before, out to however many clusters you need. I mean, that's that cluster pool concept. That's the application sync concept. That's all that stuff coming together under one hood.
Yeah, absolutely. And with this capability of managing an OpenShift cluster like you would manage an operator, an operand, as some people would say, right? And the operator controls the operands. It brings all sorts of possibilities around GitOps. I can define my clusters using YAML in a Git repo, and I can sync those into my cluster, and all of a sudden it starts going out and provisioning clusters for me. And then if I want to change them, I just go into the Git repo and make a change to the machine pool that gets synced back to the cluster. And now I've got infrastructure nodes set up on my cluster, or I've got logging nodes set up on my cluster, or I've created, some sort of horizontal scalability, right, by defining a new set of worker nodes, right, with a new label. And so I can schedule just the applications I want to run on those specific nodes. And you can do all that with the combination of Hive, which is an open source project, and like Devin said, you can go out and download it yourself and play around with it, and ACM. And I think ACM brings a higher level of management to that with some of the capabilities we have around being able to do this sort of GitOps model, especially with applications, where we can take an application that's defined in YAML in a Git repo and sync it to a cluster, and then sync it out to one of the managed clusters that we've provisioned. And it's all done with labels, just like you would deploy an application to a particular node that has a particular label. We can deploy applications to particular clusters that have those labels, and it's a very powerful concept, and something that I think developers will get very excited about. And I hope that we get to this point where we can stop treating our clusters as these precious little things. Like I always think of the Lord of the Rings and Gollum's like my precious, that's really how people treat these clusters. And quite honestly, we need to get to a point where these clusters, we just throw them away when we don't need them anymore. And that's something that Gurney here is going to be talking about with cluster pools, because it really takes that concept of throwaway clusters to a whole new level. And it has really increased the speed and productivity and just the velocity of our CI/CD team since we've started using it.
What do you say? Is it time? Can we see some actual nerdy magic?
Someone share your screen, please.
I was about to say that was a wonderful segue, Tim. I guess I'll go ahead and steal the screen share to hop in. Basically, when we started working on RHACM, I arrived a little while ago, and it's like, hey, we're doing this multi-cluster management thing. Also, that means we need lots of clusters to do CI against. We need to test everything, and we need to test it against a bunch of clusters, and we need to represent, our support matrix, all that sort of stuff. So you run into immediately the problem of, I need 4 different clusters on 4 different cloud platforms every CI run. And, if we reach an error case, I'll need new clusters to replace those, fresh clusters to really prove out that this application is deploying on a fresh platform. So we fortunately were able to, alongside Hive, leverage Hive to provide those resources for us. So we do a CI run every 2 hours. Every 2 hours on the hour, we'll attempt to do a full CI run, and that involves checking out numerous clusters for our hub, for our imports, and representing as much of our support matrices as we can. So We need a lot of clusters to really achieve that. And through that, we really end up with this problem of, well, we need RHACM to be able to do CI for RHACM. Conveniently, we've released it now, and we have the Hive folks to help us out. So we're using RHACM to do CI for RHACM. I'm going to show off a little bit of what we've started leveraging, namely cluster pools. So cluster pools are this technique like Devin talked about before, where you can have a pool of programmatically defined clusters. In our case, we typically have the supported OpenShift version, some good group of OpenShift versions represented. And we'll go ahead and we'll select clusters. We'll check them out from the pool. And rather than taking 40 minutes, 50 minutes to provision a cluster for each one of those that we need to run on our CI run, and then merging in and running, we just check them out from Hive. And in 5 to 10 minutes, they come out of hibernation. They're ready for us to go. We'll run our CI run. And then we'll check them back in, and Hive manages the whole life cycle. It'll clean them up, and you can even define a lifetime for those claims. So if you claim a cluster and your CI system just kind of blips out, you've somehow happened upon an outage, you're not going to leak anything because Hive will clean up that claim after your defined number of hours. So we'll say maybe CI run takes 2 hours, so we'll have it automatically clean up after 4. So
I think there's an important distinction I just wanted to call out. So the cluster pool, it's a stack of clusters, right? And when we create a cluster claim, it pops a cluster off the stack and assigns it to that claim. And then it goes through and using its own logic, will provision another cluster to make sure that the number of clusters in the stack always stays consistent. So the cluster you've claimed will never go back into the stack. It's yours, you own it, and you can treat its life cycle however you want, right? So if you want it to stick around, great. If you don't, delete it. It doesn't really matter. It's nobody else is going to use that cluster. It's not going to go back into the stack and get reused. It's throwaway.
Yeah, Tim, you make a very good point there. And hopefully here we are. So we have, I'm showing KUI right now. It's just a Kubernetes web terminal in part of RHACM. And I will blip over to my command line in a second, but this achieves the same goal. This is actually one of our cluster pools. So it currently says, hey, we asked for a cluster pool of size 1. We defined it on this base domain. And we have, in this case, this is an AWS cluster pool on OpenShift 461. And we pointed to an image set. We'll get into that in a second. But what it says is we have 1 cluster ready. That means there's a cluster provisioned and waiting and ready for us to check it out whenever we need to. So let's hop over and say we're going to start our CI run. We're going to start a deploy, or we just need a cluster to do a dev test run on. All of these are use cases we're kind of working on inside the organization for ACM development already. So let's pop over. So we have OC-get cluster pools. We have some cluster pools here. Hopefully we're logged in still. There we go. And we'll go ahead and start a checkout from this cluster pool, and then we'll kind of pull back the curtain and look at how these cluster pools are created and defined. And that'll let us see how you can change them up. So in here, we have a couple YAMLs. The nice thing is cluster claims, cluster pools, they're all defined in YAMLs, and you can use in YAML, and you can use ACM to sync some of these. So Josh will probably talk about some cool stuff with that in a bit. But if we look at our cluster claim here, we're going to go ahead and apply this YAML. All it says is, hey, we want it named this. We're going to do it live. And we have this, we're going to do it against this namespace. We're going to have this claim against this cluster pool name, which we have up here. And we want it to have this RBAC group. So in this case, I'll have a special user that's defined that's actually through a GitHub RBAC group sync operator that we're utilizing. Yes. So go ahead, Tim.
So that's a good important point, right? In order to preserve security, Hive will assign or create a namespace for each cluster deployment it creates, right? So for each cluster that Hive creates for you and controls the lifecycle for you, you will have a namespace with the same name as your cluster name. And that's done to preserve RBAC rules so that people who don't have access to that namespace would never know that that cluster ever exists. So the reason that Gurney is showing there that we had to pass in a subject to the cluster pool is because the cluster pool has already created that cluster. It's already that cluster already exists in a namespace. And in order for us to now access that namespace, since we're claiming it, it's going to automatically associate an RBAC rule to this group, which Gurney has passed in. It's called the CI/CD group, so that anybody who's a member of that group will have access not to the entire namespace, but just to the objects that are important to be able to identify what where the cluster lives and how to gain access to it.
Yep. Thanks, Tim. So while Tim was talking there, I went ahead and logged in as using a nice little script here, so I don't have to show my token with my GitHub credentials that only give me access to specifically the live demo, or sorry, the CI/CD cluster pools namespace. So I'll have access to the resources in those namespace. And then once I set the subject on the claim, all related resources to the claim, in this case, the cluster deployment that Hive has waiting for me, I'll have access to read. So we'll go ahead and we'll apply this YAML right here. It'll take a second. So that cluster claim has been created. So if we do an OC get cluster claims here, typoed live, as we always do.
Wouldn't be a
We'll
live stream without a typo.
Exactly. So we have 2 cluster claims here. We'll take a peek at the one that I just created, and then we'll dive over to the ones that I created yesterday, because I know how live demos go. So let's go ahead and describe this cluster claim right here. So as we can see, we have all of these details on our cluster claim. And down here at the bottom, we have a message cluster claimed, status or type pending. So it's saying, is the claim pending? False, the claim's not pending. That tells us the claim's been fulfilled. We have indeed claimed a cluster. So we can go up here and take a look and see, hey, we have a cluster pool namespace listed now. That's good news. It's given us a cluster. So we can go ahead and do OC get cluster deployment for that cluster deployment, and it's provisioned it in that namespace. So it's the cluster deployment and the namespace, same name. So you can go and take a peek at that cluster deployment, and we'll see that, oh, it's there. It's installed. It is an OpenShift 461 cluster, and it's resuming. So that means, hey, this was hibernated, which is good news because it costs us in our current, like back in napkin math, about 68% of the cost, or sorry, about 32% of the cost of a running cluster. So we've saved, yeah.
And that's a huge point, right? That I don't want people to miss. It ultimately, the cluster pools, yes, they provision the clusters and they are sitting there waiting to be claimed, but they are not running, right, until you claim them. So you can eliminate, like Gurney said, 67% of the cost of running that cluster by leaving it in the cluster pool until it's ready to be claimed. Yeah.
And that percentage, I should say, is on AWS. We haven't done any more analytics. And I should also say that's mostly back of the napkin math. This is just us looking into it ourselves. So we see it's resuming. We'll go ahead and just pop out of this and take a look at the one that we already have up and going. So let's do an OC get cluster claims again. And we're going to go ahead and dig in on this cluster claim here that I created yesterday that's been fulfilled and is on a cluster that's already there. So if we look at the cluster claim here, once again, we have this cluster claim. Take a peek. We see that it has indeed been fulfilled. And then we're going to go up and grab, once again, we'll take a peek at the cluster deployment in this namespace, and then we'll log into it and take a peek at the cluster that we now have all access and rights to. So there we are. It's now running. So this cluster has been up for about a day, and we checked it out yesterday. It's fully resumed. So we have a running cluster, and we can go ahead and get this deployment as YAML, and that tells us some important facts. It says, hey, it's no longer hibernating. We can have, and we now have the clusters reachable. So it does a liveness probe. And then we take a peek here as well, and we get references to 2 secrets that are stored in the same namespace with the same RBAC restraints that allow us to access the admin password and the kube config for this cluster. So I've gone ahead and taken the liberty of already grabbing the admin username and password. And I have this script right here that will use the password, username and password that I pulled from there to log into that cluster. Namely, it'll be a cluster named with all of this mess here in the name. And there we are. We are indeed logged into the cluster we checked out. Now, the biggest feature is, this is our simulated CI run. So this is where I, as a developer, might either run CI in a CI system or check this out and verify a bug, test my code, whatever I want, with basically no wait time, 5 to 10 minutes for it to unhibernate at most. And then, as easy as could be, I can just go ahead and say, okay, what did I call that? Cluster claim. So we'll OC get cluster claim, and it'll pop up, need to relog in. And we'll log in with my GitHub credentials, the ones that are very limited, just to access this, because I'm a lowly developer here. And we'll say, hey, I'm done with this cluster. I no longer need it. So we'll go ahead and just delete that cluster claim. And if I did this correctly, that will delete. And if we take a peek back over here in this namespace, we'll hop down to, and hopefully I guessed the right one. Under the covers, Hive is now actually uninstalling and deprovisioning that cluster, just kind of under the covers. Now, I as a developer don't need to care about this anymore, or a CI system, because Hive's doing all the work for me. I told it I'm done with the cluster is going away. So if we hop in here to the terminal, it'll show, let's see. Oh, sorry, I'm the wrong one. So either way, this uninstall job pod will actually run through the full uninstall on this cluster, and the cluster will disappear from my AWS account. So we've now gone through kind of the whole flow from checkout to check back end of a cluster. And the last thing to say is that Hive has already started to re-provision a new cluster in place of that cluster I checked out.
All right. So you can think, I don't know how many of the viewers may be working with a CI/CD team or maybe working on a CI/CD team, but you can imagine the usefulness of this, right? Having clusters on demand, ready to go at all different versions across all different cloud providers that OpenShift supports IPI installs on. And you can pick and choose whichever version you want on whichever cloud provider you want. You automatically have a cluster ready to go. You execute your tests. And when you're done with your tests, you just delete the claim and the cluster goes away.
Yeah.
That's a very, very powerful way of running CI/CD for applications that are going to be running and targeted onto OpenShift clusters. We've seen not everybody's going to have our exact scenario, right? We have to test our builds across multiple versions of OpenShift, across multiple different cloud providers that run on OpenShift. Our test matrix ends up being quite complex. But this has allowed us to simplify that test matrix quite a bit.
Yep.
I was going to ask a question there, Tim and Gurney. What was the moment of clarity when you realized, we've got this in our back pocket and we're ready to rock? Was it time? Was it cost? What pain point? Because I think that's what resonates with the users is helping them understand they may not be here today and they may not be here in 2 weeks, but they're going to be here eventually. And what brought that out for us?
So I have some great talk about this. So I arrived out of college at IBM in June of last year, June 2019. So I came into welcome, here's Kubernetes. So I got to learn what Kubernetes was. Also, you're on the CI/CD team. Okay. Also, you're working on supporting OpenShift 4, and they have this really cool installer that provisions the infrastructure for you. So immediately we're like, okay, well, at least we have a tool to provision these clusters. So we set up our whole CI/CD pipeline, and each job to represent one entry in our support matrix would provision a cluster bespoke each time. So it'd provision a hub, it'd provision an import. And what we noticed is not only does that add 40, 50 minutes to the CI build time where you're just waiting and there's some dead time where your code's not even being exercised, what you're testing is not even being exercised. But during that time, occasionally you'd hit a quota and you'd have to go in and manually restart the CI run and make sure that your resources that you'd utilized already were cleaned up. You have to make sure that you were robust enough to store that state and to manage that state. And you had to make sure that you were robust enough that if your CI CI test failed, you'd still clean up the cluster at the end. So all of those concerns came in where when we moved over from IBM to Red Hat, we said, okay, we're going to solve one of these problems real quick. We're no longer going to wait, provision on demand the clusters for our CI runs. We're going to go ahead and have some pool of fixed clusters that we're just going to pull out. We're going to clean up, run our own cleanup on, and then deploy to. But that involved us having like 12 static clusters running at any time, and we'd had to check them out. We had to make sure that we could uninstall idempotently, even in a failure case. And it really just caused a bunch of headaches there, but we knew that was a transitionary step. That saved us that 50, 60 minutes each CI run and some complication to do with state management by just grabbing a cluster from some fixed set. Now, Hive finishes that puzzle where we can really have on-demand check out a cluster, very rapid with lifecycle management that's external to the CI process, and do that at a multi-cluster scale. So we can check out a large number of clusters, we can run a CI run, and we can be sure that those clusters will be cleaned up at the end. We'll be sure that they're provisioned and provided to us, because Hive's kind enough to do retry and inform you when things go wrong in the logs. So you can, if you ever need to intervene, and we're even working on getting that a little bit more automated. But then check back in.
So to answer your question, Scott, from my perspective, it was time, right? Time in that we had to develop and continue to maintain our own Ansible scripts to do the install across all these different cloud providers, which we no longer have to do with, sorry, my screen blanked for a second, which we no longer have to do with by utilizing Hive, right? Hive's an IPI install. It works across all the different cloud providers, and it takes care of everything for us. So we don't have to maintain our own Ansible scripts. Not that there's anything wrong with that. It's just extra work that we have to maintain, and we don't want to have to maintain it. And we had to maintain it for every cloud provider and every version of OpenShift, which is not terribly difficult. We were doing it.
You were doing that for a couple of years, and you know the
right.
idea.
Yep.
You
right.
know when that system goes down.
Right. And we were having to help developers with anytime they'd have a problem with those scripts, we had to spend the time to help developers with it. And now we don't have to, right? Now we've got Hive to do all that for us, which is great. So that's one aspect of time. The other aspect of time is the 45 minutes it takes to deploy that on demand, right? Now we don't have to wait that, right? We wait 5-10 minutes max for it to unhibernate, and it's ready to go. That, is extremely valuable when you're looking at a velocity of trying to get as many builds done in that 8 hours of productivity time per day. I mean, especially with COVID, right? Everybody is working from home. Everybody's on these meetings. Everybody gets a little tired and aggravated eventually, right? So the more we ran builds, the more aggravated we got with this, the concept that we were using before we started using cluster pools, which was we kept the same clusters around. We reused clusters, right? And the point of that was to keep our build time, the distance between our build times around 2 hours, right? We didn't want to exceed 2 hours. We wanted to capture every single change that was coming in as quickly as possible, identify those changes so that it would be easier to fix when we found problems, right? And the amount of change that goes into a build in 2 hours is less than the amount of change that goes into a build over 8 hours, right? So it's easier for us to debug the problems and identify the issues if we have less time between our CI builds. So utilizing cluster pools allowed us to move away from reusing clusters, because reusing clusters is a horrible idea.
Mm-hmm.
And the reason being is because you leave artifacts around, right? You leave artifacts around, and there are so many objects in Kubernetes. It is impossible to clean everything up, right? As much as we tried, right? We even came with I finally got frustrated and wrote a nuke script just to try and delete everything I possibly could.
Warning.
Let's not talk about the nuke script at all. I don't want to remember it.
So Hive, cluster pools eliminated that. We had a fresh, brand new, pristine cluster every single time we ran our CI. And it only took us 5 to 10 minutes to grab it, right? We didn't have to wait 45 minutes for it.
And it saved you a bunch of money too.
Right. And the added benefit, because to me, time was the number one issue, right? and the ability to spread this out across all of our supported test matrix. We have an enormous test matrix, right? We've got to support 4 different versions, 4 different Y versions of OpenShift. Plus we have this kind of shady, not shady, let's say not well articulated Z stream support, right? That is, well, maybe we support, X -2 or Z -2. Maybe we support Z -10, right? We don't really know, right? That's one of those, at least from a CI/CD perspective, it's very hard to test, right?
Yeah, huge challenge.
Yeah. So we can stand up these cluster pools with every supported version of OpenShift, all the way down to the Z releases, on every cloud, and we can randomly select these clusters from any of these cluster pools to run our CI tests on, and we run 8 CI tests a day, right? So statistically speaking, over the course of release, we're hitting every single version and of OCP that we need to test before we ever go out the door and release it. So that is a time constraint. Now, to Josh's point, the cost savings with hibernation was just like a nice added benefit. It was like the chocolate you get on your pillow when you go to a hotel, right? It was like, oh, wow, they do care about me.
I don't know.
Right?
I don't know what those hotels are, but
I know it's been a while since all of us have gone to a hotel. I understand. Unless COVID has wrecked your marriage, in that case you might have been in a hotel for a while. I'm not sure.
That's a different podcast.
Right. We won't go there. But yes, I mean, ultimately it saves time and it saves money and it reduces complexity, and all of these things add up to increased velocity, right? And we have seen a huge increase, not only in my CI/CD team's productivity, but in our velocity and our ability to contain all of these different CI processes that, frankly, everybody is relying on us to contain, and not just the developers, right? Ultimately, we're responsible for making sure that everything has been tested and thoroughly evaluated before it ever releases to the general public, and so it's something we owe our customers to do.
One addendum, Tim, we run 24 CI builds a day since we're cross geo, so it never sleeps. It runs on weekends as well.
Good point.
This also gives us another point, is this gives us the scalability of this system is just impressive, because before when we needed to add a new version to our cluster pools, and I realize now I completely forgot I'll click over here real quick. I'll do a quick overview. If we need to add a new OpenShift version to our represented cluster pools, it is quite simply as easy as adding a cluster image set. So let's go ahead and just take a peek at this one. All we say is, hey, I want you to be this version of OpenShift named this, and I want you to point to this release image. So you just change out this version, and ta-da, you have a new cluster image set. Now, one thing of note, these are global resources. So the admin on the cluster will have to provide these, which is really a good thing, because these are what is used to provision these resources. So you kind of don't want that going awry. So we'll go ahead and log in as the kubadmin user, and let's just apply this. We'll see that, and we'll make us a new cluster pool. And this is how we're able to scale. This is what we do every release. OpenShift puts out 4.6.1, and I went through this process to add 4.6.1 for GCP, AWS, and Azure to our CI matrix. So it's as easy as just doing an OC apply for, let's see here, our cluster image set. And now we can see that we have a cluster image set right here. Go ahead.
Yep. And so it's super easy to set this up and use it. And I think the documentation on the Hive site is not quite there yet, but I think I think there's a PR coming for that real soon. But I was able to go in and figure this stuff out without any documentation just by looking at the CRs, right? Which you can find in that Git repo. But I'm just now realizing that Josh Packer was trying to do a nice segue into what he wants to talk about
Oh yeah,
with
yeah.
hibernation, and I completely blocked him on that. So I do apologize, and I think we should move on to what Josh
That's a
Packer.
good idea. We promised him 15 minutes, didn't we?
No, I think I was only promised 10 minutes. So I was looking at the clock going, it's all right. We're all good. And so, yeah, I mean, I kept mentioning cost, and cost comes up day 2 as well. And so I'm going to talk a little bit about how we're leveraging, again, the hibernation function that Hive makes very easy to access and takes care of all of the heavy lifting for us. And so really, you or I or we as ACM specifically are just left with creating the business logic around how do I want to implement these? When do I want to implement these? And so as Gurney was saying, our developers come, they get these clusters. And for us, we are a cluster provisioning, automation, and day 2 management product. And so everybody just deploys ACM Hub onto these clusters that came out of the pool. And the next thing they do is they spin up 3 or 4 or 6, hopefully not too many, but a bunch of additional children clusters that come out of that ACM. And so even though ACM was asleep, we powered it up. So we had been saving money. We bring it in, they get it quickly. They've suddenly created a bunch of clusters out of ACM that are now running. And when running 24/7, starts to add up across our 3 cloud providers. And so what the problem gave us was we came up with sort of 2 different solutions. So one is a opt-in model for hibernating. And so that's where I can curate a list, as an example, of clusters that I would want to hibernate. And the other is an opt-out model where we try to hibernate everything that ACM by default, because developers may not remember to curate in their labels, etc., for it. And so we will put everything to sleep. So without further ado, let's take a quick look at some of these and how they work. So the first one, we'll do the opt-in model, which is we use a GitOps scenario, and we actually leverage the application model that Tim and both Gurney touched on at the beginning. Let me just share the screen here. So this is our cluster list page. So we see I have an ACM hub that was provisioned out, and then I've gone out and I've built a bunch of these clusters with Hive. And so Hive can build across, we support 5 platforms out of the box in the UI, which is and sorry, I'm going to do a little plug here, but is the Amazon, the GCP, the Azure, the VMware, and the bare metal. And then as well, you have OpenStack that you can still use the Hive through the APIs and CLIs as well. And so what we wanted to do was come up with a way to do a curated hibernation of these systems. And so what we did was leverage our applications. And so we say applications, and you think about running my web server, or another one, I think we did the demo last time, was the Pac-Man application.
Yep.
But really, the subscriptions and our application model will allow you to work with any Kubernetes resources. And so here we have an app that we created called Cluster Hibernation. And so in that, we have a subscription for hibernating and a subscription for resuming. And what that does is we're able to curate inside of a Git repo. Let's bring that up here. So this is the open sourced one. It's available today. Actually, I'm in the fork, but it came from Open Cluster Management, Cluster Hibernate. So you can fork your own copy. You can put it into private mode if you want to secure it, but it allows you to, the repo will allow you to create a set of directories where you can place the different clusters that you'd like to put to sleep. So if you were paying attention, where's the screen? Here we go. If we hop back over here into our clusters, we'll see we have the AWS, the Azure, and the GCP. And so all you need is a very simple piece of YAML that's going to modify this cluster deployment object, and Hive has made it dead simple. Literally, we changed the power state from running or blank to hibernating, and in about 2 minutes or so, Hive will have shut down the cluster in the native cloud provider. And so that works for AWS, works for GCP, works for Azure. And so in something like AWS, when you think about a developer's core work hours of, let's say, 8 to 6 p.m., Monday through Friday. In a 28-day cycle, that's only about 30% of all the time you would otherwise be running a cluster if you left it on 24/7. So again, you can see it's a pretty big, it's a 70% savings that you can cut off there. And again, if you need to bring it back, let's say I come in on a Saturday and I want to bring the system back online, well, it's just a matter of flipping that state. And so again, we'll use the visual web terminal here just to show. So behind the scenes, when the subscription is applying to Hibernate, it's looking up that cluster deployment object that we just saw. Put the get in here. And so we can see we have a couple of these for the different clusters. And then it's just making a mod to the single parameter, which is the power state, which we'll find down here. So it's running. So you can make the change. And even here, I can make the change directly, and I can move from running state over to a hibernating state, and the system will make the switch. Get the, oops. And so I'm flipping it here, and I'm going to save it. And so this is what the subscription does on the back end of the system to do it. And you have full control because it's in the UI here. So we can go back to the application. We'll click on the hibernating, we'll click edit. And so just the idea here is the subscription is leveraging what we have is the time windows. And so I can pick the time of day where I wanted to execute the change on the cluster. In Git, I defined all of the clusters that I wanted it to hibernate. And then at that time, it's going to apply those to the system and put them all to sleep. And so in this case, it's at 7 p.m. It's going to change all of those power states to hibernating. So this was the opt-in, where you're curating a set of clusters that you want to turn off. The other one we created was because Gurney asked me, would this work if the developers just created a whole whack load of clusters and didn't take any action? And the answer is no, because this was an opt-in model. And so we built a very quick opt-out model, in which case we were going to hibernate everything unless you opted out by putting a label on the cluster to say to skip it. And so again, this one is available in the open source as well. And I will admit, this one was, I had never had an excuse to use a Kubernetes cron job. And this seemed like the perfect opportunity to use a Kubernetes cron job, as well as all Linux developers will be familiar with the cron job. So we created a very simple little app that runs in, or image, I should say, that's able to reach in with a very limited service account and read the cluster deployment object and make patches to the cluster deployment object. So it doesn't even need permission to create the cluster deployment object. It's just a very limited set of list and patch and get data for again, that cluster deployment object that comes from Hive. We do the manage clusters, so you can put labels in different places. But again, it's as simple as to turn all of your clusters on and off. You specify a cron job setting for a time. So this is in UTC. So at midnight, which is like it's 4 hours off. So it's 6 p.m. Eastern time. It goes through and it will shut off all the clusters in the in that ACM hub. And so the idea being is we're going to start to preload this into our clusters that we've pre-provisioned with the cluster pool, so that each evening when a developer goes home for the day and forgets to have turned these off, and they had 3 of them, and I'll throw a number out there, a 6-node cluster in AWS for just the AMIs, you're looking in the $700 range every 28 days for that cluster. And so this will turn them off. And if you were to turn them off between 9 and 5 or 8 and 6, Monday through Friday for a 28-day period, that's 20 workday business days and 4 weekends, it reduces the cost to under $250. So it's a pretty big, significant savings. And the flip side to make this easy is if I do need the system back though, and again, this is if you've checked out the Git, we have a couple of different make commands, but we created some manual jobs that'll allow you to bring them online or bring them offline as well. So you can just do something as simple as run a make running, and this is going to go off and launch the job that's going to go through. It's going to flip all those bits. You can also do what I did manually, which is you can just bring up the cluster deployment and change it from hibernating to running to bring them back as well. But so it's very easy to bring them off and online with Hive. And the other piece I can't stress enough is if you did this manually and you were going over the 30-day certificate cusp, or you've hibernated it within the first 24 hours of deploying this cluster, you've got to go in and manually approve all the certs as OpenShift comes back up. Hive takes care of all those pieces for you. And so it literally is as simple as changing a single line on a resource to bring these things up and down now, which is very powerful. But for the most part, it's also there's a huge savings in scenarios where where you have to have all these clusters, but you may not be using them all the time. And so those are both, it's two ways, an opt-in and opt-out model. With the opt-out model, you just have to create a label on the cluster in ACM and the job will skip it. So we do once in a while have a cluster that someone creates that they need to leave long running. They have that opportunity. And so these are both, we made them open source so that you can play with them. One is more just a demonstration in our how to use our subscription application model. And while the other one is just a pod you can run in the deployment. And again, we have the full readmes for them. So they're pretty straightforward to use. It's a couple commands is it to get them up and running.
Just wanted to contribute as well. There's also a setting on the Hive cluster deployment that you can use to say hibernate after and then specify a duration so that if it's been running for a certain period of time, it'll automatically get put to sleep as well.
Exactly.
I know Gurney's been peppering your team, Devin, with a handful of other enhancements to bring it all together. Looking ahead, ACM delivers Hive within our product. So we've actually had a couple of customers that have come forward leveraging Hive in the open, and they've come forward and said, oh, now I can get RHACM, have full support, have all the goodness and baked in application, policy, day 2 config, everything we handle in the full breadbasket of feature set with the Hive functionality under the hood, that they know they can drive these cluster pools, they can drive hibernation, they can drive OpenStack, which is already in Hive in the API layer. So all that bucket of goodness is there, ready to rock, ready to go. And we look for your team, and the OpenShift installer and what's going on the ground level for the infrastructure management. We look to you guys as kind of giving us signals, but now it's coming full circle where since we are consumers of it and using it in-house, we're able to drive back enhancements to improve things for the CI/CD flow. Anyway, it's been cool to work with your team and to see this develop out in the open and get value from it right away. I know we've got to be cognizant of the time here because the Zoom call is going to self-destruct in 4 minutes. But we've covered a lot of ground. Chris, I want to hand back to you for a minute. Did we miss anything in the chats, or is there anything that sparkled in your mind that we should cover?
I mean, I don't think we missed anything in the chat. Let me double check. I mean, we covered IKS, we covered VMware, we covered bare metal, and everything else. I feel like if there's any questions that may come in, I can get them answered after the fact, folks. So feel free to email me, cshort@Red Hat, and I can get the various people plugged in and get you the right answer if you need it. No, it looks good, I think. All good.
Nice. So you got to see ACM, you got to see cluster pools with Hive, you got to see Visual Web Terminal, which is our in-console multi-cluster
fancy schnazzy.
Yeah, management tool there. Tim, your points were spot on. I kind of want to give you a minute just to kind of recap on where we're going with CI/CD, how you see this use case evolving over time. Give us some insight as to how we're building this for our squads to consume it internally and looking at broader adoption inside of Red Hat.
Yeah, so that's a good point. So we've been using it with CI/CD for just the CI/CD use cases, specifically around our CI Canary testing processes. We've been doing that for about 2 months now with great success. A few hiccups here and there, but we've been submitting issues to the Hive team, and they've been very quick about getting those fixed and resolved for us. And at the moment, we're pretty happy with where we're at. Now we have seen a significant cost savings, right? Between what we were doing. Like I said, what we were doing was leaving these clusters up and running and reusing them. And now that we've switched over to Hive, they're not up and running all the time. They're hibernating. So we've seen a significant drop in our cost just from the CI/CD processes. We are rolling this out to the entire development org for ACM, not entire Red Hat, just ACM. But it's about 60 developers, right? We are spread across about 10 different squads. Each squad has its own AWS account, but it has its own GCP account, own Azure account, right, for cost control. And those guys will be all using a single cluster, and they'll be logging in with their Git. It's all authenticated against our GitHub org, and they have their own namespace. So they all share a namespace. So each squad has its own namespace, and they can create their own cluster pools. And how they manage those clusters is completely up to them. We're giving them the control that they need to be able to control their own costs, right, for their own development needs. And we're basically empowering them. And I think this is very much a use case that most customers, right, will have, right? You may run production on-prem in your own data center, but you're likely using the cloud to do development, and you certainly want an easy way to stand up the clusters that you need and an easy way to control your costs.
Awesome.
Well
All
said.
right. Yeah, that very well said. Okay, folks, we're going to be stream jumping here. The next stream we'll be doing some chaos testing. So if you want to take what you've learned here and then apply some chaos testing, which works very well with ACM, I feel like, because you can spin things up and down very quickly. Join us here in 30 seconds.
Awesome.
And thank you all for joining today. Thank you everyone in chat. Thank you everyone watching. Thanks the 5 of you from the ACM team for joining. Always bringing the heat there, Scott. Thank you very much.
Y'all be safe. Thanks again.
And
So am I a Twitch star?
yeah,
now?
stay. You are a Twitch star.
Yeah.
Welcome to it.
I can tell my children.